our next speaker, who's someone I've gotten a chance to know through a number of interviews, and has given me a sense of a way of thinking that should be far more common, and is exemplary of an older generation, people who have a sense of the development of human civilization, and also a cultural development that's continuing to take place in the Trans-Pacific, in China, in Korea, India. Dr. Chang is a professor emeritus from San Diego State University. And he's had an opportunity to work not only on water projects in California and the United States, but was fortunate enough to participate and contribute his expertise on water resources and river management to the largest construction project known to man, the Three Gorges Dam, as he would put it. So I'll leave you on one note. In a recent interview, Dr. Chang mentioned, he said the one thing interesting about solving problems is that you're always going to create another problem. And I think that's why the universe is so good. So, Dr. Chang.
Well, thank you. It's certainly my pleasure to share my personal experience with you. I'll try not to use a microphone. Well, what I said was the following. Once the problem is solved, new problems are created by the solution. So engineers, we are going to solve problems continuously. We are going to open up new frontiers. Does it work better with the microphone or without? With it. Okay, very good. Well, I'm going to talk about water engineering problems, not only in the United States, but also outside the United States as well. The story must start from home, which is California, where we all call home, right? We have so many major engineering projects, water engineering projects in the state of California. I'm going to get into the details right after this. Let's start from the beginning, give you the outline. We have the California Aqueduct, which diverts water from Northern California to the Southland. We have the Los Angeles Aqueduct, which diverts water from Owens Valley to the Los Angeles area. We have the Colorado Aqueduct, which takes water from the Colorado River into Southern California, including San Diego County. We also have the irrigation project that takes water to Imperial County. You can see from this picture, parts of California are green. The Central Valley is green. The Imperial Valley is green. Now, that appearance is strictly due to irrigation projects. By the way, the irrigation project in Imperial County, now, All-American Canal irrigates so many acres that large-scale farming is so productive. You know, that was desert area. That irrigation transformed the desert wasteland into the natural hotbed of USA. That large-scale farming is so productive. It can feed the entire population of California. We also know Central Valley. Now, irrigation for Central Valley, irrigation for Imperial Valley. The agriculture for California can actually feed the population of the United States. California and Iowa are the most productive states in agriculture. Now, all these are because irrigation and water-related projects. Well, let's see. You may or may not know the water supply system for Southern California supplies the water need for 20 million people in 7 counties. Now, in these 7 counties, over 90% water used in the 7 counties is actually imported from these 2 or 3 major aqueducts. Now, the water supply system for Southern California is one of the 7 wonders of the modern world. 7 wonders, including the Panama Canal. Okay, this system is one of the 7 wonders of the modern world. Let's think about how much has changed. Do you remember that story? When water was diverted from Owens County to Los Angeles, San Fernando Valley. Remember that story? How land price skyrocketed, right? When water was brought to San Fernando Valley, it completely transformed the physical nature of Los Angeles and San Fernando Valley. Well, let's see, slide.
I want to show you the details of this diversion project. That water comes from the backside of this high Sierras, right? That canal and diversion system feeds water to Los Angeles and the San Fernando Valley. Okay, next one. Now, this is a picture of the trunk canal for the All-American Canal, which diverts water from the Colorado River to Imperial County. Now, this one irrigates so much land. And by the way, the agricultural area can be greatly expanded should there be more water available. Right now, they're actually sharing part of the water to San Diego County because they can sell that water, which they got at a cheaper price, to San Diego County at a much higher price. San Diego pays much higher price per acre foot of water than Imperial County. Okay, next one. Well, you see, water and power cannot be separated. Whenever you have water, you have power generation, hydropower generation at the same time. Give you one example. On the All-American Canal, now that canal has a slope flatter than the natural terrain. Therefore, it is built with a series of grid control structures, drop structures. The drop in water surface elevation from upstream toward downstream is roughly 50 feet. Well, that 50 feet is the head that is used in generating hydropower. This one is a power plant. Okay, water is fully utilized for not only irrigation water supply, but also for power generation. We're going to spend more time to talk about hydropower, especially the advantages and the benefits of hydropower as compared with other sources of power. Okay, let's go back again to California. High Sierras, we have so many small streams and larger streams. Okay, the waters of the High Sierras, I can tell you this, is the hardest working waters of the world. That water is fully utilized. We built so many storage reservoirs. You may not see this in this picture, but we built so many water storage reservoirs. When we utilize water, transfer water, water has to be stored first, right? Because rainfall does not come uniformly with time. It changes from season to season, changes from year to year. By the way, this year, last few years, we have a drought in California. We are under water use restriction in San Diego County. You can only irrigate water year long on certain days with a limited amount of irrigation time. Okay, there's definitely a need of greater water supply for this entire region. Well, let's see, the High Sierras. I want to show you a project I worked on a few years ago for Southern California, for Pacific Gas and Electric, PG&E. That's a very large power company. They supply 50% of energy for the state of California. Oh, they have all kinds of power plants. They have hydropower plants, they have nuclear power plant, Diablo Canyon, they have fossil fuel burning plants. I want to show you the plant, the hydro plant on the Rock Creek, on the Feather River. See, here's Feather River. Okay, here's the tunnel intake. Here's the intake. That tunnel goes through the bedrock over the total length exceeding 10 miles. Hey, they excavate a tunnel through the bedrock for 10 miles. From this point to a downstream area of the river, there's a drop of elevation of 700 feet. From the intake to the outlet, the drop in elevation is 700 feet. That is the head. And there's a constant flow, a few thousand cubic feet per second of water going through the tunnel. And that 700 feet plus the flow rate is used to generate hydropower. Well, there are 3 such stages along the Feather River, maintaining a constant flow rate. Okay, that total power capacity is 1 gigawatt. I would say 1 gigawatt is the average capacity of 1 nuclear power plant. But think about this. If you want to have 1 nuclear power plant with the same capacity, okay, let's say if the revenue, a few years ago I happen to know, 1 gigawatt, the revenue for that energy you sell is about $1 million a day. That energy is worth $1 million a day. Okay? Now, for this 3 power plants on the Feather River, the operating cost is nearly zero because, hey, it burns no fuel. There's no fuel cost. Hey, there's no transportation cost for fuel. Okay? And also, they only hire 30 people in the entire canyon. So the costs for generating hydropower is very low. On the other hand, in a nuclear power plant, okay, the operating cost to generate 1 gigawatt is close to $1 million a day. So the profit for nuclear power plant is very, very small in comparison to a hydropower plant. Now you can see the difference. Well, one reason it's so expensive to operate a nuclear power plant is the safety measures. Okay, there are so many regulations for operating a nuclear power plant. That's why they have a large staff at each generating station. That's why it's so expensive to operate a nuclear power plant. Well, Hoover Dam. Well, that's very important. You know, in 1929, this country had a major depression. And one of the means for getting out of the depression was the construction of Hoover Dam. Okay, Hoover Dam, of course, provides Lake Mead for water storage. Well, Hoover Dam at the same time generates hydropower. The capacity here is, I know it's over 2 gigawatts. It's almost like 2 nuclear power plants. Well, you see the importance of Hoover Dam. Lake Mead supplies the water used in Southern California. We need that water storage, right, for water supply to Southern California. In fact, the very existence for the city of Las Vegas depends on the water supply from Hoover Dam, from Lake Mead, depends on the power generated from the hydropower stations. Well, of course, the western part of the United States, the very development of that depends on the supply of water and the power to this entire region, and the Hoover Dam is one such major project. Okay, I want to share some experience with you on major water projects in China, which I also got involved. Let us now compare the geography of these 2 nations. These 2 countries are similar in size, similar in latitude, in climatic zones. However, this shows the population distribution. China has a population that is over 5 times the population of the United States. Okay, but in terms of water resources, United States is number 4 in terms of water resources. Number 1 is Brazil, of course. Brazil is the most abundant nation in water resources than all the other nations. United States is number 4, and China is number 6. Think about it. With a huge population, with limited water resources, therefore water utilization becomes a very important issue in China, but in many other developing nations, with the exception of Indonesia, which is abundant in water resources. I want to show you the distribution of water resources in China. This map here is the rainfall distribution. The heavier the color, the greater the rainfall. I just mentioned Indonesia is abundant in water resources. I believe Indonesia is number 2 in the world, only after Brazil. Well, let's see. This area is fed by the water supplied by the monsoon. By the way, monsoon feeds 50% of the population of the world. Okay, but you can see rainfall distribution in China is highly uneven. There's more rainfall in the south and more rainfall in the north. The vast area of the northwest is very dry. Well, because of uneven distribution of rainfall, to solve the water problem, it requires water redistribution. Because the population distribution, they also have a large population living in the north. They have very sparse population living in the west. Therefore, water from the more abundant area needs to be transferred to the north. Therefore, water diversion becomes a very important task in that nation. But before you can divert water, of course, water has to be stored because the rainfall is not uniformly distributed in time. Well, there are years we could more have rainfall. And certainly in the summer, there's more rainfall. There's much less rainfall during the winter time. Well, with this basic understanding, we know the importance of water diversion, water storage, okay, in this country. Okay, this shows the population distribution, more detailed water population distribution. Okay, you see, there's a lot of people living in Asia. China and India have the largest populations of the world. And rainfall distribution is concentrated in the south and much less in the vast area of the west. Well, I want to take you to the far western province of China, the Xinjiang province. I was out there about 5 years ago. Let's see, I want to show you a picture I took. Show you the desert area. That province, I say 80% of the province is basically a huge desert, the Gobi Desert, one of the largest in the world, only after the Sahara. Well, try to stabilize the drifting sand. They use drip irrigation. I understand they learned this technology from Israel. Well, Israel is very advanced in irrigation because of the need and also in desalination. The drip irrigation, okay, try to stabilize the drifting sand. They have highways, they have, well, for different reasons, the drifting sand must be stabilized. Well, let's see, the Yellow River, part of the Yellow River flows through the arid region of China. I happened to be out there 4 years ago. I took this picture. Along the river valley, you could see oases because water was taken from the river for irrigation purpose for the farmland. So this area is very green. But as long as you go away from the river, you see very dry landscape. They have really developed a lot of irrigation projects along the river. I want to show you some examples. Well, let's see. For people living in the arid area, well, they have their measures for storing water. Say, for example, here's the roof, here's the pavements, right? During the rainfall, water is not drained away. Water actually is collected into the underground cell. This underground storage, they actually build an underground storage tank. Water is collected from the rainfall, from the roof, from the pavement area into the groundwater storage. And that water is used when, of course, when it is in need during the dry season. And let's look at some of the irrigation projects. They took water from the Yellow River. They built huge pumping stations. See the lift, the total lift. This is a 3-stage lift taking water from the Yellow River. The total lift exceeding 1,000 feet. Taking water from much lower area into the high plateau area. I want to show you the interior of the pumping plant. Okay, here's the electric motors that pumps water up. Total 3-stage pumping over 1,000 feet to irrigate huge amount of land. I understand there are 30,000 people living in that area where the water is strictly supported by the pumping system. I want to show you the facilities, small irrigation facilities, small canals, man-made canals, control gates for distributing water, and also small canals that goes directly into the farmland. You can also use aqueducts across the valleys, distribute water. You can look at the landscape, how dry the landscape is. In a way, much like California and Arizona, we all live in the arid region. Okay, well, a very major project, the Three Gorges Dam, was built on the mighty Yangtze River. The color here shows the drainage basin, the watershed of the Yangtze River, which accounts for 50% of the water for that entire region. Okay, that's the drainage basin of the Yangtze River. And here's the city of Shanghai. That's the city of Beijing. Okay, Taiwan is right here. Well, let's see. Let's see how they're going to utilize the water of the Yangtze River for power generation, water storage, and so forth. Okay, see, here's the drainage basin of the Yangtze River. Three Gorges is located somewhere here. A small gorge. But it controls roughly 2/3 of the drainage basin of the river. Therefore, there must be a lot of water flowing through the gorge. Yangtze River is very similar to the Mississippi River in size and also in the amount of water. The average flow rate for both rivers is roughly 1 million cubic feet per second. There's 1 million cubic feet of water flowing through the river cross-section per second. You can see the abundance of water flow for these two major rivers. The Mississippi River and the Yangtze River are very similar in size and also in capacity. And Three Gorges controls, well, at least 2/3 of the drainage basin. There's so much water that would have to flow through the gorge. Power generation depends on two factors. Depends on the discharge, depends on the flow rate, and depends on the head, depends on the drop in water surface elevation. That's what we call the head in hydraulic engineering. In fact, power is equal to the product of the discharge and the head. Okay? So the greater the discharge, the greater the power. The greater the head, the greater drop, the greater the power. Let's keep that in mind. So if they can build a dam with a huge discharge, with a large drop in water surface elevation, and a lot of power can be produced, right, based upon these two conditions. I want to show you the schematic of the layout. Here is the dam, and let's see, there's the spillway. These are the turbines. That's areas where turbines are installed along both sides of the spillway, and they have a lift, ship lift. Ships and boats can be lifted from the lower side to the upstream side. Lower side is the downstream side, upside is the upstream side. Of course, there's a huge difference in water surface elevation. It also has locks and dams because large ships would have to sail up and down the river. In fact, ships as large as 10,000 tons can sail through the gorge. You have a series of lock and dams. Well, we have many such facilities in the United States. The Panama Canal has many such facilities, lock and dams, because of changing water surface elevation, and the ships would have to go through from one elevation to the other by going through a series of locks and dams. This one has got several stages. And this one is from the satellite view of Three Gorges Dam after its completion. Here is the dam, here is the lift, here is locks and dams for ship passage. We'll see a close-up. Okay, this again is a schematic view of the project. And here is a satellite view when water was released from the control gates. Okay. And you can see a close-up water from the downstream side. Now you can really see the scale of this dam. By the way, the total project cost was $30 billion US, including the resettlement of 1.2 million people. Wow, you know that. Well, there's a big political question here. They settled 1.2 million people to different parts of the country, to higher elevations. People ask me, what if we want to build such a project elsewhere in the world? Say, if we wish to settle 12,000 people in the United States, I'm sure what your answer is, right? It's out of the question. Well, they have to take very ambitious measures because they want to solve a big, big problem. Okay, the water problem far outweighs so many other problems. And by the way, This project is the largest project in modern times. This project surpassed all the 7 wonders of the modern world, of the Western world, by a very, very large margin. Okay? Well, in terms of the magnitude, in terms of the cost, in terms of the total effort. Next picture. You see, water was released from the control gates during a recent storm. A big question arose. During the planning stage of the project, there were many oppositions. Well, the Chinese government contacted the U.S. government for technical and financial support. The U.S. government designated U.S. Bureau of Reclamation, which is the water engineering institute in the United States, to look into the technical cooperation and support for the project. Well, it was the determination of the U.S. government that the Chinese EIR, Environmental Impact Report for this project, does not meet the U.S. standard. Therefore, the U.S. government withdrew the support of this project, completely withdrew the support of this project. Well, that was the bad news. The good news is that they no longer use the engineers from the U.S. Bureau of Reclamation. Hey, I got the job to work as a consultant. You know what the major issue was? There were oppositions. Not only outside the country, but also inside China. The president of the Chinese Academy of Science was opposed to the project. He said eventually the reservoir created by the dam will be completely filled up with sediment. That's what he said, because he said that impact cannot be mitigated. And that storage reservoir, that big project eventually will become a waterfall. He said, how can I support? That's going to be a sorrow for China in the long run, right? So the number one issue in this case is reservoir sedimentation. I'm going to address that subject because I happen to be the person who worked on the research and development, tried to look into solutions, of solving the problem for reservoir sedimentation. That's the most important issue we shall discuss, okay? Well, another view of doing the water release. Next. Okay, I thought I'd show you, going back to the sketch. From the upper reservoir to the lower river channel, you see the dropping elevation is roughly 100 meters, 320 feet. That is the head. Now, water flows through the penstock, which is the huge pipe, and it drives the turbine at the downstream end. So it's the flow rate and the head that determines the power capacity of the generator. Here's the turbine. Turbine is driven by the flow, and turbine drives the generator. The generator is right above the turbine, right? Well, by the way, those turbines are huge, huge turbines. Each turbine has a capacity close to 1/2 of one nuclear power plant. No, sorry, 1/3 of a nuclear power plant. I used to have that number, okay? Now I'll tell you the total capacity of this project. The total capacity of this project is 18 gigawatts. That is equivalent to 18 nuclear power plants. Now you can think about the magnitude of this project. Then we're going to compare, the difference between hydropower and other sources of energy as well. Well, another view. And let's look at lock and dams. Going from the downstream side to the upstream side, the difference in elevation is 100 meters. Ships and the boats would have to go through many stages, locks and dams, right? To go from one way to the other. And this is a view of the locks and dams along the along the ship channel, okay, the aerial view of that. And let's discuss important aspects of the project. First of all, it is cheap energy in the long run. I mentioned that to you before, right? About the Feather River. The project, well, because you have water storage, it has the benefit for flood control because the storage capacity of the reservoir can reduce the flood peaks. Flood peaks are the most damaging to the downstream areas. The flood peaks can be reduced because of the capacity for water storage, because you have controlled the water release, thereby reducing the flood peaks. That's the advantage for flood control. And then navigation. Oh, there's a very interesting development. There's a very big city on the upstream side of the Three Gorges Dam, what is called Chang. That city right now has 20 million people. Now that city can now reach the ocean by major ships. Okay, because of water transportation, that is a very important factor for the development of that major city. Before that, what about navigation before that? There were rapids. There were rapids, very shallow water, very high-speed water going through the Three Gorges area. So large boats simply could not, okay, sail up and down the river. But right now, even ocean-going ships can sail and up down the river. I would compare Chongqing right now to the city of Chicago. Chicago, of course, is connected to the ocean by St. Lawrence Seaway. Now the city of Chongqing is connected to the ocean because of Three Gorges Dam and the improved navigation through the Three Gorges Dam. And of course, water storage also creates a water pond, right? There's going to be fishery products. And what is most important, hydropower is renewable energy. You know, right now we're talking about low carbon energy nowadays. There are different ways for generating low carbon energy. And the most important way happens to be hydropower. There's wind energy, there's solar energy. Well, right now there are many such projects going on in the United States. There are 2 solar energy projects going on, one in Imperial County, the other one just south of Barstow. Well, they are still at the development stage. There are so many wind energies. Wind energy is being developed in the United States because we know, we hope someday 10% of energy produced in this country will be from renewable energy sources. And hydropower happens to be the most important renewable energy, okay, among different ways. And why? Well, we know the importance of energy. In fact, we have energy crisis, right? We have energy crisis, not only in this country, all over the world, because energy is the foundation for economic development. If we are going to enhance the livelihood, the economic activities of this nation, make this country wealthier and stronger, of course, we're gonna have good supply of energy. Source of energy, including, I have listed, coal, that's fossil fuel, oil, nuclear, hydropower, solar, wind, and etc. And the hydropower is ideal source of energy because of the following reasons. First of all, there's no fuel cost. Hey, you don't have to buy coal. You don't have to buy oil. You don't have to buy uranium. There's no fuel cost. Secondly, no shipping cost for the fuel. You don't have to ship coal to the power plant. You don't have to ship oil to the power plant. There's no shipping cost for the fuel. And non-polluting, because there's no carbon generated, and then no waste produced. Hey, that waste is a very big issue for nuclear power plants. Nuclear waste will remain radioactive for thousands of years. We have found out nuclear waste disposal is a big headache. Where do we store them? We store them underground, thousands of feet underground. We dig very deep tunnels, right? We stored nuclear waste underground. That is very expensive as well. Well, then, high initial installation cost. Of course, it takes a lot of money to build a hydropower plant. I have calculated the cost of generating 1 gigawatt of power for a hydro plant is very similar to a nuclear power plant. In other words, initial cost is very much similar on amount of energy produced, right? However, afterwards, your operating cost for hydropower is very, very small, extremely small. But for nuclear power plant, operating cost is very high because of the safety regulations. Even for other fossil fuel burning plants, the operating cost is also very high because they require to buy the fuel, shipping costs for fuel, and plus all kinds of costs. Now, previous. The Three Gorges installation is the equivalent to 50 million tons of coal per year. Think about it. 50 million tons of coal. That is, okay, if you want to generate using coal-powered plant, that's 50 million tons of coal. Think about it. Let us now make a comparison. The major hydropower generating stations of the world. Three Gorges is the giant among the giants. These are the rated capacity, these are the power dams and the country. Three Gorges, I say 17,000 megawatts, let's say 17.7 gigawatts, right? 17.7 nuclear power plant capacity. The next one is the one in Venezuela. The next one is Itaipu, Brazil. Oh, I happen to know the story of Itaipu. That was built something like 30 years ago in Brazil. Okay, that was supposed to be a huge hydropower plant. And Brazil didn't have the money to build it. You know how they raised the capital for doing that? Hey, they built the whole thing using a charge card. Either Visa, American Express, whatever. They just charged it. Charge. By the time they finished the project, there was inflation in Brazil 1,000% a year. That is the consequence of borrowing. You're going to see the consequence if you borrow too much money. Okay? we better pay attention to our country, United States. Well, Grand Coulee Dam in the state of Washington on the mighty Columbia River is the largest hydropower generating station in this country, 6.5 gigawatts. Well, Columbia River has a lot of flow in comparison to the Colorado River, right? That one doesn't have very much head, but the discharge is huge. Then we have, let's see what else we have. Oak Creek, 3.6 gigawatts. Hoover Dam, unfortunately, does not make the list because its capacity is less than 3 gigawatts. But you know Hoover Dam supplies so much energy, okay? A good portion of energy for our region. And, well, big issue, as I said. A very important issue here is reservoir sedimentation. That's why so many people were opposed to the construction of Three Gorges Dam. You know, I have sailed on the Yangtze River. I sail on the Yangtze River in the summer. I sail on the Yangtze River in the winter time. It was muddy in the winter. It was muddier in the summer. You know what the difference was? The only difference between summer and winter is between muddier, and the muddiest. Because the water was muddy all year round. The water has a high sediment content. That is a major concern. If you build a dam, create a reservoir, you are slowing down the flow velocity, which will reduce sediment deposition in the reservoir. That's something everybody understands. Then the big question is that going to mean eventually the reservoir will be completely filled up with sediment? Okay, well, that is the most important issue to address. We built so many reservoirs in this country. You know, I stood on Hoover Dam several times. I look at Lake Mead. I see clear water in Lake Mead. You know what message I get? Well, your message and my message are different because I happen to be a hydraulic engineer. I see clear water in Lake Mead. Is what you saw in Lake Mead? Clear water, muddy water? Clear water. You know what message I get? No sediment can escape Lake Mead, which means Lake Mead eventually will be filled up with sediment, except that time span is very long, measured in thousands of years, because there's several other dams, Glen Canyon Dam, that also detains more sediment. Glen Canyon Dam gets a lot more sediment deposition than Hoover Dam. Okay? But Yangtze River is so muddy. Even in this country and all over the world, the average rate of siltation is 1% per year for reservoirs in the world. Without proper sediment control, a dam will eventually become a waterfall. Well, that is the most important issue. That's why the president of Chinese Academy of Science was opposed to the project. He wrote a letter to Jiang Zemin, even before that, who was that? To Deng Xiaoping, he wrote a letter to Deng Xiaoping. He said, I strongly oppose to the construction Three Gorges Dam project. He gave all kinds of reasons, right? Well, then, of course, there was research and development before the construction started. I happened to be a part of the ball game on the very subject of reservoir sedimentation. The question is, will the reservoir eventually be totally filled up with sediment? Well, of course, when you do a research, you know what you do. There are different ways of doing research in hydraulic engineering. There's what we call physical modeling and mathematical modeling. Physical modeling is when you build a physical model to simulate what happens when the dam is finished, how much sediment would actually accumulate in the reservoir. Mathematical model is what you do using a computer. You use a computer to simulate what happens in the reservoir. Okay, of course, the part I did was computer simulation of reservoir sedimentation. I want to show you, well, when I said muddy water. Well, let's see. This was before the construction of the dam, okay? See, water was quite rapid because water was flowing through the gorge, quite shallow. Well, this ship is a very shallow draft, by the way. Otherwise, it could not sail in that river. The water was muddy, clear. The water was muddy, very muddy and very shallow. It's very clear in this picture, right? And the Colorado River is in much better shape in terms of sediment content. So sedimentation was serious concern. Here's the gorge. Here's the gorge. Next. Well, let's see. This picture shows reservoir sedimentation. This is a small reservoir in northern part of China. You see how the reservoir was almost totally sealed up. Even if you drain all the water from the reservoir, you're not going to flush the sediment. You only cut a small gully. Most sediment stay in the reservoir, right? Okay. However, the Three Gorges Reservoir is different because it is a river reservoir instead of a storage reservoir. River reservoir is long and narrow. Okay? Well, it's a river reservoir, therefore certain speed of flow can be accomplished. And besides, okay, the dam has low-level outlet to pass sediment. The dams are built with low-level outlet to pass sediment. Then the reservoir level can be drawn down. You can raise the water level and lower the water level. During the summertime, there's more flow. They lower the water level to increase the speed. And reservoir operations are made during floods. During floods, you have a lot more flow. You lower the reservoir level, you achieve the flow velocity to flush the sediment, to pass the sediment through the reservoir. And research was done in a physical modeling study. Here's a physical model to build indoor to see what happens. And you would think sediment would settle in the reservoir bed, right? To make the reservoir shallower and shallower and shallower. Not so. Because there's a flow, because there's a river flow, sediment actually settles along the banks, not necessarily along the bed. Because there's a river flow. The river flow would always create a channel. That river flow would actually become faster when there's sediment deposition along the banks to establish a narrower channel. Let me say this, our conclusion is the same. That reservoir will undergo siltation. 40% of reservoir capacity will eventually be lost to sedimentation, but the remaining 60% will be preserved in perpetuity. So that reservoir will never be filled up because there's a river flow. The river flow would always pass the sediment through the reservoir. Okay, well, we have a lot of discussions, conferences, and so forth. This is one of the pictures in the conference. But what is most important for that country is the water diversion project from the south to the north. Because there's much more water in the south than in the north. So they are going to build 3 diversion channels from the Yangtze River to the Yellow River and further north. Okay, let me show you. Here's the eastern route. Here's the Shanghai. That is Beijing. You see that? This is about 700 miles in distance. Here is the eastern route along the ancient canal. Okay, here's the central route. Takes water from a tributary of the Yangtze River to the city of Beijing, and this takes the water to the city of Tianjin, and there's a branch to the tip of the peninsula. These are the major water diversion projects. And there's the western route. The 3 routes combined will divert so much water, 7% of the water of the Yangtze River to the north. How are they going to benefit? How many people are they going to benefit? I say at least 70 million people would actually benefit from the diversion project. That's got to be the largest diversion project ever undertaken by man. Okay, by the way, you may not know, the city of Beijing, right here, is on the edge of a huge desert. The annual precipitation in Beijing is less than 20 inches. And there are 20 million people living in that big city. The local drainage simply will not supply the water need for such a huge population. So with the water diversion to the city of Beijing would benefit so much from the water diversion project. Okay, a new city will be built between Tianjin and the coastline. That city will be the second Shanghai. Okay, that's going to be the 3rd largest economic zone in China. Well, before that, that city could not be developed. That's wasteland. And because of freshwater supply, they are going to build a second Shanghai outside the city of Tianjin. Okay, that water comes from the Yangtze River. The Yangtze River to the Yellow River, and then Yangtze River to the city of Beijing. Those are huge diversion projects. And this is the canal, the ancient canal in its current state. It's out of repair. And this canal will be deepened, enlarged, and dredged. Well, it would also provide improved navigation from the south to the north. And a new canal will be built. This shows they're actually working on the project. You can see the construction of the new canal. Okay. By the way, from the Yangtze River to the Yellow River, there's going to be 13 pumping stations, locks and dams, right? Boats would have to pass. There's going to be 13 pumping stations. And from the Yellow River to the city of Tianjin, that's strictly by gravity flow. That's dropping elevation, so water will flow by gravity. But for the central route, the difference in elevation from the source water to the city of Beijing is 100 meters. Water will flow strictly by gravity, no pumping stations in between. Okay? Let me show you. Of course, the water is going to cross the Yellow River, under the Yellow River, by a huge tunnel. Oh, this one doesn't show the size, but the Yellow River is a huge river. You can see the tunnel, the size of the tunnel, intake, an underground tunnel going through the Yellow River and going to the north to the city of Beijing. The water flows strictly by gravity. There's no pumping stations in between. I want to show you the western route. Western route is the most difficult. It takes tremendous investment. They're going to take the river, water from the Yangtze River to the Yellow River, to the upper reaches of the Yellow River, through very rugged country, high mountain areas, deep valleys. You see, from the source, okay, from the Yangtze River to the Yellow River, the dropping elevation is only a few meters. Water tunnels gone through a huge series of huge tunnels. By the way, 90% of that diversion system is tunnels. Huge tunnels. That takes huge investment to build that project. That is only part, only route that where the construction has not started. You can see the western route going through the Tibetan Plateau, on the edge of the Tibetan Plateau. See, crossing all the mountains, crossing all the valleys. There's going to be a series of dams to be built in the valleys. There's going to be a series of tunnels going through the mountains, going from the Yangtze River to the Yellow River. Okay, the supply water from the producing area to the consuming area. Well, let's see. So 7% of the water will be diverted from Yangtze River. 7% of Yangtze River will be diverted to the north. But how are they going to replenish the water for the Yangtze River? Well, I'll tell you what. There are three parallel rivers. Here's China, here's Myanmar, that's Burma, right? That's India. There are three rivers which are parallel. Here's the Yangtze River. There's a center river that flows into Mekong River in Vietnam. And there's another river very close to it, goes into Burma. These three rivers are so close to each other. They are going to build 12 high dams on these rivers. Water from the other two rivers can be transferred to the Yangtze River. But that brings up an international issue of water rights. It was an issue for the Colorado River, right? We use most of the water inside the United States. When the Colorado River flows into Mexico, it's a trickle, right? So they have to solve the water right issue because these two rivers are international rivers. The United States is very fortunate. Mississippi River is not an international river. Well, the McKinsey River, Yukon River are international rivers. But fortunately, we have agreement with Canada to solve the international issues. But people actually predicted there's going to be more international issues, perhaps even wars, because of the water conflict. We also, Mesopotamia, the civilization of Mesopotamia, relies upon the water supplies by the Tigris and Euphrates, right? You know, the source of water is where is Turkey, where the rainfall occurs. And Turkey is in the process of building two huge dams and the water storage. So the water flowing into Iraq would actually be controlled by Turkey. So that is international water issue. Well, have used up most of the water the time. Do you have? I wonder if you have time for discussion questions.
We got 5 minutes.
Thanks for your presentation. My name is Frankie Medina. I work with LaRouche. As far as I remember, I came around in 1979. There's always been a drought. Like that's always been the normal natural state of the Central Valley, the San Joaquin Valley. My question to you is, what work has been done in terms of the feasibility of seeding clouds? Because all the reservoirs, like the Pine Flat Reservoir, the Terminus Dam Reservoir, Millerton Lake, all these things have dropped, like the part of the Central Valley project. They've all dropped in water level. And I was wondering how, I mean, to have a reservoir, you need snowpack, you need rain. So what work has been done in terms of creating more rain? That's it.
Well, cloud seeding has limited effects. You've got to have the cloud first, right? There's a fundamental. there's a fundamental way to change the climate pattern, precipitation pattern. That is, if you can modify the jet stream. Jet stream carries the water. If you can change the jet stream, move the jet stream further toward the south, okay, then we can get a lot more rainfall, like El Nino year. So that is the fundamental solution. But I don't think it's an easy task.
I worked on several projects in refineries in LA, and we extracted water from the ocean through desaltation plants on the refinery to use to make industrial grade water on the use on the cooling towers rather than using the potable water. I wonder what % of water could be done through desaltation.
Okay, I happen to get involved on a desalination project in San Diego County. That, in fact, is going to be the largest one, has been approved. Now, that's going to build in San Diego County and the Batiguitos Lagoon. Water will be taken from Batiguitos Lagoon, going through the reverse osmosis. Well, now they are looking for a buyer right now. Who is going to buy it? Because that water will have a unit cost twice as much as the current water in San Diego County. But if you're talking about industrial grade, of course, that process doesn't have to be so detailed, right? Maybe that water won't be as expensive. But desalinized water for drinking grade water, that water is, that process is energy intensive. So therefore, it's quite expensive. It's twice the price of the current water we use.
There's also gray water. You drain the bathtub, and you could fill the toilet with that water and flush the toilet, because you don't break out the toilet.
Yeah, from toilet tap. Well, actually, we have toilet tap already, because the wastewater treatment plants for the city of Las Vegas all drains into Lake Mead, and we use the water as our tap water. It's from their toilet to our tap.
I have a question. If we control the clean water, we don't allow them to flow into the sea, and the consequence will be we will change the density of the sea, and what will happen doing that?
Okay. Well, let's see. The previous presenter already mentioned we are going to transfer the water. Of course, I can change salinity, right? I'll tell you what. The sea is so immense. The ocean is so immense, right? Whatever we do to the salinity of the seawater, I believe is quite limited. Say the seawater in near Saudi Arabia, in Persian Gulf, must have a higher salinity, right? And the seawater near the mouth of the Amazon River has low salinity. That fresh water goes into the ocean for miles. But whatever we do actually is quite limited. Quite limited. That's why there's a saying, man learned to master nature by understanding, not by force. We must follow Mother Nature, because Mother Nature is so mighty. And whatever we do is so limited, even for Nawapa, the water we divert. I don't believe the impact would be that huge. I don't believe the impact on salinity would be that huge either. That's my personal opinion. Yes.